Okay, so today we're going to get into physical properties of materials. Physical properties, they can definitely influence material selection, because you have to know the physical properties of the material in order to design a product. So when you select the material, you definitely need to think about them, because they can influence, manufacturing. They can also influence the service life of components. And physical properties, they have effects on product design. They also have effects on service requirements and compatibility with other materials. So here you're thinking about the material to make a product, and we're thinking about the physical properties of these materials. So your material got to be compatible with your tools, your dies, and your workpiece. For example, like you can be able to use a die, made of material that is lower in physical property than the material you choose. So you have to compare, and your material and your tools, your dies, your workpiece, they have to be compatible, right? Okay, and your strength to weight. So when you think about your product, right, product design, this is what we always think, We think about the strength of our product, we think about the weight of the product. So we study the physical properties of the material. We look into this too, right, ratios, stiffness to weight, here strength to weight. These ratios are extremely important, and their combined properties are important. So what are we doing? We need to know them in order for us to be able to select the right materials, especially for lightweight structures like your airplanes, high performance structures, in many different products that we need. And again, two ratios, strength to weight, and the other one is stiffness to weight. Alright, so the next physical properties is your thermal conductivity, thermal expansion, because of the heat, your material expand, your material can be able to carry heat, So they play major factors in the development of effects. What kind of effects? So the effects that are important in tool and also in our die, life, in various manufacturing operations, like thermal stress, thermal fatigue, and also shock, right? So they are the effects, right, that can be able to come out from these two, thermal conductivity and thermal expansion, physical properties. And again, your foundation, right, dealing with heat, that's your physics. So those of you who haven't taken physics, I have been teaching you so many times what's going on inside of the material, internal structures of the material. They're moving, they're moving in their own ways, not our ways, but moving. And every time they move, something is going on, and that's your electron. And we talked about it, the flow of your electron is your current, right? So electricity, is conducted, and some form of thermal energy is conducted, and because of that your material moves. So every time they move you can see the expansion, and sometimes you can get stresses because that movement is going on all the time. Of course it's going to give you stress in your material. Sometimes they got tired, okay, the material inside get real tired for conducting some energy, especially electricity, or sometimes magnetism came, and all of that can stress can fatigue the material. Okay, why? Because they move the internal little particles. Remember, we talked about that in class. Since they have to move so much, of course they stress and they fatigue, and sometimes they get shock if you're not careful about what like what type of heat you're subjecting to the material. Yeah, so sometimes they can get shock. So therefore, these physical properties are very important. And then we will get into oxidation, corrosion. So they are, of course, every time we think about oxidation and corrosion, chemical, chemical like, chemical looking like, so chemical reactions, and they're important. Again, material selection to make your product. Design, of course. The design is we're literally shaping, okay, our material, and depends on the shape this can happen, okay, over time. So manufacturing as well as in the service life of components. So every product they have life, and we don't want oxidation, we don't want corrosion on their surfaces of our product, right? So therefore they're very important to consider every time we select the material, every time we design our product, and during manufacturing processes, right? And also in their service life. Alright, then we get into passivation and stress corrosion, cracking. So they're just the phenomena, and we can see these phenomena in material selection, in design steps, also in manufacturing, and also in service life of these components. So meaning like when you have like corrosion, right, just a chemical reaction in your product, and they can stretch out, and because of that stretch, right, you can get a crack inside of your product, okay, sometimes on the surface of your product. So therefore you've got to consider these physical properties again for these four things. Yeah, this is repeated, saying it again and again: material selection, design, manufacturing steps, and the service life. And we call that passivation, stress corrosion, cracking phenomena that is important. Okay, they are very important to think about it. Meaning like we have to be careful about their physical properties of the material, right? And one of them is this. Okay, on the next two effects and physical property that we have to pay attention is your magnetostriction, and the other one is a piezoelectric. Okay, so they're just the physical properties, and we use them in manufacturing processes and their control. So you might want to review what magnetostriction is. It's just nothing. It's just your sample, or okay, or your material, let's say, is magnetized, and then you can be able to see its effect. So piezoelectric is nothing but you're gonna see like some electric charges, and sometimes they accumulate, okay, or they stay in, especially in the solid materials, okay, like ceramics, okay, in a material. Then we want to see what happened to all these effects. Okay, so how can we see them? So the first one is your magnetostriction effect. You can see, okay, this effect ultrasonic machining of materials. So that's the way we can be able to understand, right, magnetostriction effect. So if you think about this magnetostriction, where your sample is, okay, magnetized, you can be able to see it in ultrasonic machining. Piezoelectric effect, so where can you see them? So you can see this effect in transducers and also in various types of sensors. For transducer, it's a force, all right, transducer, that you can be able to see this type of piezoelectric effect. Okay, so for the general, right, I would say like the summary for your chapter 3, okay, physical properties, not so much. If you can be able to recall, right, strength to weight, stiffness to weight, your thermal conductivity, your thermal extension, your oxidation, okay, your corrosion, and they're very important, right, because they can influence in material selection, design again, yeah, manufacturing, and your service life. And if you can be able to remember that, you are good. And of course, you pay attention to your magnetostriction and your piezoelectric effects. Yeah. All right, that's it for this chapter.